Welcome to a video on vector components. So let's have a look at the components and column vectors. So a unit vector is a vector of length 1. So that is, the absolute value of the vector is equal to 1. Every non-zero vector has a corresponding unit vector. So we can calculate the unit vector, which will be represented by A with a little hat over it, and it still has the same direction. It's just a unit of 1 length in that direction. So to calculate it, it's the vector over the length of the vector. Perpendicular vectors have a common tail and they meet at right angles. So obviously the obvious thing about perpendicular is fine. So, but just the component that, or the concept that they meet at right angles and they have the common tail. And components of a vector, so we say that along the x-axis is going to be the I component and along the y-axis is going to be the j component. I know that's not easy to see in this, but if I want to represent the vector u, that would be I length across the x-axis plus j length across the y-axis. You can also represent it as a column vector. I will tend to use this a lot more. So that can be in square brackets or curved brackets. It doesn't really matter. One of the main things is, so obviously you have x and y, just like you would with a set of coordinates. So that's the x or the I value over the j value. So the I value first and the j value second. We can add the x's and we can add the y's. So that's a very simple one to remember. To find the length, so the length comes from Pythagoras. So I've set that there as the vector squared, so is equal to x squared plus y squared. So we would actually just use whatever was in the column vector, the two values that were there. So it's the square root of x squared plus y squared, and the angle tan theta equals the y over the x, so that's opposite over adjacent anyway. So some things are just, we've used anyway. If I want to find the x coordinate, I can use the length of the vector cos theta, and to find the y coordinate, it is the length of the vector times sine theta. So here's some past questions. So we've got from the 2020 HSC, Maria starts at the origin and walks along each of those vectors, how far from the origin she is. So I'm going to represent them as column vectors and then have a look at that operate. The second one from the 2021 is given OP is -3, 1 and OQ is 2, 5. How do we find PQ? That's from the first video, how to actually figure that one. And then we're going to evaluate these, the addition of vectors where we've got a multiple of one of the vectors. So the first one, so the vector 2i plus 3j can just be written as 2, 3. The vector 3i minus 2j can be written as 3 minus 2, and the vector 4i minus 3j can be written as 4 minus 3, and we're just going to add them. So you can add the x's and add the y's. So you get 9 minus 2. How far? So how far is a length? So we just use our use the rule that says that the vector squared equals x squared plus y squared. So substituting in, we get 9 squared plus minus 2 squared. So the length is the square root of 85. The second one, OP equals -3, 1 and OQ equals 2, 5. One of the rules we learned in the last one was that if I want to find from P to Q, that is OQ minus OP. And you can do that as a visual as well if you want to be able to look at that. So therefore PQ is 2, 5 minus -3, 1, which becomes 5, 4. Third one, let's write u and v as column vectors. So I minus j is 1 minus 1, and 2i plus j is 2, 1. And I want 3 lots of the vector v. So we are going to get, adding them together is 1 minus 1 plus 3 lots of 2, 1. And that gets us 7, 2. On to 3 others that haven't necessarily been tested because it's only been a short time frame, but just how we actually operate with these. Bit different questions, but you'll see them. They're good questions and they appear in the textbook. So if I've got the vectors A 3, 2 and B 2, minus 1 and C 10, 2, I want to find the values of M and N such that MA plus N lots of B vector equals the C vector. For A hat, we're going to use the rule that we had before. And if I want to find the length and angle of the A vector minus 2 minus 3, so we'll look at how that operates. So we're going to equate the coefficients of I and j to form 2 equations for this one. So obviously you would understand or know that if I'm making 2 equations, I am creating simultaneous equations. So for the first one, M is for the I, we're looking at the I components, so M lots of the A. So let's focus on the I components. So 3 lots of M because the M is multiplied by the A, and 2 lots of N because the N is multiplied by the B is equal to the C, which is 10. Then we focus on the J components. So 2 lots of M minus N equals to 2, and we're going to solve them simultaneously. So simultaneous equations, you know how to do that. So M equals 2 and N equals 2 is what you should have got. For the 5th one, how to get A hat. So remember that is the vector divided by the length of the vector. So this allows us to find the unit vector. That's what we're trying to find. The A hat is the unit vector. So the length first is the square root of 4 squared plus minus 3 squared. So the length is 5. So multiplying you can divide by 5, or multiplying the original vector by a 5th, you get 1/5 of 4i minus 3j. That is the unit vector. And for the final one, find the length and angle. So the length again is just using Pythagoras. So it's absolute value of A is the square root of minus 2 squared plus minus 3 squared. So that's a square root of 13. And using tan theta equals minus 3 minus 2, taking into consideration that if you were to plot minus 2 minus 3, you would be down in the 3rd quadrant. So therefore we would do like any OR station. So central, we're going to add 180 degrees to the vector. So you get 56 plus 180 and you get 236. Thank you.